Hey, hello, welcome to the show. It's me, John Park. This is John Park's Workshop, and we are here to make stuff today and look at stuff and talk about things and more. Thank you so much for stopping by. We've got people over in our chats. Hello in the YouTube chat to Baragraf Avdelhagen and Dave Odessa. Thanks for popping in. And of course, our Discord chat, which is a great place to check out if you are wondering where the chat is and you're somewhere else. And hey, where's the chat? That's it right there. Go to adafruit.it/Discord, look for the live broadcast chat channel, and pause the distracting video in the corner there. Whew. Hello to, who we got? Let's roll back here. I think we start off with David Glaudet. Hope I got that right. Also David, WA90NY. Hello, Andy Calloway. Hi, hey Thin Man. Hey Blitz City DIY. Liz, how are you? Hey, some nice. Starman, howdy. Stuff, and more stuff, Andy Calloway, that's right. So, pop on by. I apologize once again. I have had a weird issue with launching the Facebook. Oh, is it going? Oh, maybe it's live. It's showing a preview as if it's running, but then the go live button is grayed out. Maybe that's running. Who knows? I'm gonna move away from that. So what's happening here today? I have a discount code for you if you want to buy some stuff in the Adafruit shop. I've got a recap of the product pick of the week. I've got a nifty CircuitPython Parsec for you. I've got a Learn Guide recap, and I have a couple of project things. I want to talk a bit more about the Fruit Jam and Metro RP2350 versions of the Larzio Paint Music program. And I'm kicking off something. I have an upcoming project that's going to involve some synchronized NeoPixel lighting using WLED. And the way that I'm going to be doing it is new to me. I haven't done any of the syncing stuff, so I thought I would try to fumble my way through that live on air. And if it's not too excruciating, you can watch along. If it gets out of hand, I'll do it offline, but I think it might be interesting to see that get tackled fresh. What's that involved to do some WLED syncing between a couple of instances on some Sparkle motion boards that we'll be using. So that's the show. That's what I've got planned. Let's now move into coupon code territory. Coupon code today is Maskatron. Maskatron. You remember Maskatron, right? From the $6 Million Man? If not, that's okay. Just type it in. Head on over to Adafruit. Look for some cool stuff. This is it right here. If you go to Adafruit, let me move the coupon code out of the way a little bit for you. And Go to the main page of Adafruit. You'll see we've got a little new products section. You can click on View All New Products and see what's what. Oh, these are in stock. Hey, Raspberry Pi Pico 2 with header. So that's pre-soldered ones. These are neat. I have some of the original Pico with these pre-soldered headers. Not only is it pre-soldered, but it's a really nice header that has these support beams running between the two rows. So it's nice and sturdy. You can pull that out with less fear of flexing the board, because I have to tell you, 40 of these pins plugged in to a breadboard or a perma-proto board of some kind, or sockets, or even these guys that I was showing the other day, these little tripplers. It's not easy to pull those out, so having these sturdy headers on there, kind of nice. So you could get 10% off on that if you wanted to pick that up. A couple other cool things in here. We've got some USB-C power analyzers in a couple flavors, some USB-C power delivery cables. I just ordered one of these right here. This is a sync and data USB-C cable that has an on-off switch on it, which is great because sometimes I'm unplugging and replugging power to power cycle a board, and this is a way to just do that with a switch, which is kinder on the ports for sure. So you could go and pick up some of those things, and on the way out, you can type in the coupon code Maskatron. That'll get you 10% off. Anything you can buy that we can put in an envelope or a box and ship to you is gonna qualify. Sadly, no software gift certificates or subscriptions get that discount, but it is good on stuff. So go get some stuff if you want some stuff. Stuff. All right. Next up, Todd asks, is this the live broadcast VAT channel? It is not. Is that a tariff joke? VAT? I'm not sure. Either way, look at that. That was Tuesday's show, the product pick of the week show. Did some cool Pico Bell, I can never decide how I want to pronounce that, cameras. Here is a little 1-minute excerpt. Check it out. It is the Pi Cowbell camera breakout for Pico and Pico 2 using the OV5640 camera module, the 5 megapixel sensor, a micro SD card slot built right on there, and we have some sample code that will just take JPEG photos and save them right onto the card there. This is that 120 autofocus, and that's me there. Hello. And we're getting about 4 frames a second streaming there, so you're not going to do high performance stuff on it, but it's pretty good for a viewfinder. Here is the big honkin' 160 degree sort of fisheye style wide angle lens. You can see how wide angled that 160 is, and you can see it gets kind of distorted, fisheye style. It is the camera Pi Cowbell breakout for Pico and Pico 2. Woo, righto, that is what it is. All right, next up, I'm going to get set up here so that we can do a little thing I like to call the CircuitPython Parsec. CircuitPython Parsec. Hey, all right. Oops, did I break that? Hold on. I thought I had made a new instance of this window. Nope, I just obliterated the old one. All right, let me go reconfigure that to look at my code editor. We will get to WLED, just not yet. Come here, Zed. There we are. All right, how's that look? I think that looks pretty good. Let's fix that. Disco tool. Yes. Okay, perfect. For the CircuitPython Parsec today, I wanted to talk about how to use a button bit mask with Seesaw inside of CircuitPython. That's right. It's so easy to say. So when we're using a Seesaw chip, such as the one on this little gamepad cutie plugin, we get the benefit of talking to our microcontroller over I2C and taking care of little GPIO things right on board with the little Seesaw chip. And to keep things fast, we can send bundled up little messages about what's going on this external board, so that we don't have a whole slew of messages to get across the idea of, let's say in this case, 6 different button states. So the way this is done is with a bit mask. In the case of this seesaw breakout for the buttons, and I'm going to ignore the potentiometers of the thumb stick there and just talk about these 6 buttons here. We have A, B, X, Y, select, and start, just like a little game controller. If you look down in the REPL there, when I press a button, you can see the A button, I'm making the letter A capital, B is capital, X, Y, select, and start. So let's take a look at this first example of the select button. When I press that, all of these are pulled high. These are buttons that are pulled high, and when they press, they go to low, they go to ground. So you can see some values in that binary output there that has all the zeros and ones. The very farthest to the right says 1, so that is the current state of the select button. When I press it, it goes to 0 because it's gone to ground, and the message contains the state of all the buttons. So you can see when I press 4 of them there, we have 4 of those 1s going to zeros, as well as my little capitalization there. So this 1, it's actually a 16-bit integer that gets sent, and then I'm unpacking it into binary here, as well as these little strings. This 1 message conveys the state of all of those buttons. The way this is done is we're going to import the Seesaw library. Then I'm going to specify which pin each of those buttons is on, and that's just in the documentation for this board here. So the, for example, select button is on pin 0. That's why it ends up being that very first one. The start button is actually pin 16, so that's going to be very far off to the left there. Then we create this button bit mask. So this is the variable that contains the pin assignments for all of those buttons. And then in the setup here, we say, hey Seesaw, pin mode bulk, so take a whole bunch of pins and set them to input pull-ups. So that's a little convenience script there that sets up all those pins to be input pull-ups using that variable, that button mask that we came up with. Then in the main loop here, you can see I'm casting buttons to equal a big bulk read, which is digital read bulk and the button mask. So that grabs that full set of values there. Then we just have some parsing of that so that we can display that on screen. But if I just need to use that for, let's say, a game, we're just going to read this and then ask for those individual values of buttons. And so you can see here, as I press these, we get a nice efficient single chunk of data that contains all of those buttons all at once. There they are, all getting pressed at once, and we don't have to wait around for them as if we were asking multiple times. And so that is how you can use a button bit mask with Seesaw inside of CircuitPython. And that's your CircuitPython Parsec. Button bit mask, button bit mask, button bit mask. I should have practiced that. That's a hard one to do. Okay, so let's now move on. We've got a few different things I wanted to talk about. So, oh yeah, thanks. Todd mentions over in the chat. Let me bring this code back up. Nice to use this fancy terminal escape code to make for a nice display. So I actually did a CircuitPython Parsec on this before. You can see that we're not scrolling a bunch of data on my little REPL there. Instead, I'm just keeping that one static display, which is way easier to read in this case than if it were sort of streaming with every button press. And so I'm using some of these little cool terminal escape codes like end equals /R to redraw that text in the same spot over and over again. Clear it, redraw it, clear it, redraw it, instead of scrolling. One other thing I did, which you didn't get to see, is when we reset this, I can do a soft reset in the REPL with Control-C followed by Control-D. I'm just printing out a little information text here at the very beginning when the button mask is created. I'm printing the button mask there is the 16-bit integer version of that. And this is sort of unpacked version of that, unpacked into the binary form, which is easier to kind of understand when we're talking about these binary buttons that can be on or off. So those, I think, are kind of useful little things for wrapping your head around it. But then the sort of key thing here is down in the main loop to ask the Seesaw chip for a bulk read, tell me what all of those buttons are set at, and then we can go and parse those to do something. All right. Let's see. We'll move on to, I won't go too deep into this, but I did want to give a little recap to the Learn Guide for computer space. That's this guy back here. Battery should still work. Let me flip that on. A little computer space simulation. So here is the Learn Guide, which just got published. You can see a little turnaround there in the thumbnail. And I've got a little demo movie there. You can see it in action. Some history here, as well as I think some helpful links if you're interested in finding out more about the game, some emulations or simulations that have been done of it over the years. I've got some nice links there. Some really great web pages or websites that archive information about this, including advertisements, different interviews that have been done over the years with some of the creators. Over in the YouTube chat, Nitakri D. Paul says, nice, very 1950s sci-fi feel to it. Really, it is such a gorgeous display, or cabinet, rather. It had a 13-inch black and white consumer television, a GE, in it. So it was not a fancy arcade monitor. It was definitely not a vector display, although the PDP-1 Space War, I believe, was originally a vector display, and then Asteroids, which came later, was a vector display, but this thing was a raster running on very few lines on a black and white TV. So I've got the parts list here. I've got a section on coding. So this I created using Claude AI in Arduino and referencing the PDP-1 simulation that had been created that I linked to. So the easiest thing to do is to grab this UF2 file. If you don't want to deal with Arduino and flashing it, you can put your microcontroller into bootloader mode. This tells you how to get there. Some links here to the setup for that. Just drag that UF2 file on and it'll run. So there's the code if you want to actually dig through it. Here's some sprites, some different angles of the spaceship sprites and so on. And a bunch of routines for drawing. So you can dig through that. It's got some decent amount of commenting on it, so hopefully it should be clear if you check that out, what's going on. And then here's a little info on 3D printing the cabinet. I mentioned that there's a really nice scan of our original cabinet, which I think I have a link to, and you can download that from Printables. I used that as a reference, but modeled it from scratch using subdivision surfaces inside of Rhino so that I could make a more efficient model for adjusting things. I didn't want to deal with a bazillion triangle polygons, so instead I had sub-D surfaces. Oh, I want to mention actually, Andy Calloway just popped up in the chat. It's reminiscent of the video game in Soylent Green. It is the video game in Soylent Green. That is the only existing white cabinet for computer space, which I think was made for CES show. It was a prototype one made for CES show, and then it got borrowed by a art director or set designer on the movie Soylent Green. So that cabinet in the apartment there in Soylent Green is a incredibly rare computer space. I don't know if that one still exists or not, but yeah, that's the one. So getting back to this, I also modeled a actually, I wanted to say regarding the 3D model. So I designed it in sub-D surfaces, and I showed some of that on this show as I was working on it. And one benefit there is it's the minimum amount of geometry to work with to express the shape. Then I went and did some solid modeling to carve out spots for the screws to go and attaching things, at which point the way I was working in Rhino using Grasshopper, the parametric modeler, it spits out a multi-patch NURB surface, which no one is going to want to deal with. So that's kind of my end model. I then created a polygonal mesh, which is quite dense, so that it's very accurate. So that dense mesh is what you end up 3D printing. That's kind of always how it works with 3D printing, no matter kind of what format of geometry you're working with, NURBS or solids, parametric stuff, polygons. At some point you're going to make lots of tiny little polygons, sort of the limit surface version of the model. So if you look at the model I have there, it looks high poly, and that's why, even though the earlier version was lower poly. So there's a little bezel I created to cover up the OLED. You can see it. There's the screen, which is quite large and sort of a wide ratio. And so I used that mask, which is also in the original game. However, the mask was not really masking much of the TV because the TV was already a 4:3 ratio. But I created a little 4:3 ratio with sort of nice rounded arcs and corners there for the screen to peek through. And the way I printed it, I used some of these nice, actually I have them here, I meant to show these last time, some of these nice tree supports. So it's printed in, here's an empty one, it's printed in this orientation on the bed, as an earlier iteration. On this one I didn't use any supports and kind of got away with it. It's kind of fuzzy and weird in there, but it still works the same. But on later iterations I printed support, and this is using the Bamboo Slicer program there, Bamboo Studio. I was able to specify these kinds of tree supports, which means we have the minimum amount of geometry on the print bed, and then it forks out to cover a wider area at the top. It's just faster and more efficient to print that way. And then you just snap these off. So that was printed with also some smaller ones up where the bezel is there, so you can see them in that photo in the Learn Guide. Andy Calloway said, Yanisku7 said, PCTG seems to be the way to print transparent things. I haven't printed translucent, transparent stuff in a while. I don't have any filament for my current printer that's like that. Or maybe I have some PETG. I think I have some translucent PETG. Resin printing seems to be the way to go, says Andy Calloway. Yeah, this would be a nice one to try on a resin printer as well, I think. And then I have my little assemble the mini arcade. So this shows what the wiring is. It's good to test this out on a breadboard. Make sure it all works. You've already flashed the feather at this point, so you can go ahead and try it out once you get things plugged in on a breadboard. I just show photos here of the sort of second iteration after the breadboard, which is putting a set of cables together and plugging it all into a I'll show you the final one here, into the, oh, that showed the wrong one. That's funny. Oh, you can see right here, that is the feather on a feather doubler, and then just using the little breakout on the side there. That was kind of a nice way to go. Here is setting in the bezel, screwing into place. I used some heat set inserts there to screw into that. And then I have a nice little vinyl sticker you can download and print for the control surface. Here's mounting that feather doubler to the base, put a little rubber feet on it so it doesn't slide around, plug in the cable, and you're ready to go. I did add, this is really meant to be kind of plugged in all the time, but I did add a switch and a battery to mine, which you can see back there, big honking battery and a little switch to the enable pin so that you can turn it on and off if you want it to be fully portable. And there you go. Okay, so let me know in the chats if you've got any other computer space thoughts or questions. Oh, Dave Odessa asks, talking about pick of the week, whatever happened to the mystery wonder cabinet of drawers? That's a great question. Yeah, on the Product Pick of the Week show for the first, I don't know, year or so of it. I used a hardware cabinet I have back there and filmed a little reveal every week. Just in the interest of time, that took another 20 minutes out of my life to film that, edit it in, play it, keep track of it. So hopefully you don't miss it too much, but it means I have more time to work on projects and get you some learn guides and cool content that might be more useful than just a mystery video. Question in the chat, is there a feather breadboard? There's not a specific feather breadboard. If you go to the shop link on Adafruit, if you look at either, I think there's a Pico breadboard or a Pico PermaProto. Yeah, so this Monk Makes breadboard is pretty cool. Let me see, can I make that image bigger? This is really cool because it shows you the pinout on a Pico. I don't have one of these. I've never gotten one of these, but it is pretty darn cool. If you're doing Pico stuff, it solves the problem of there being no silk screen on the top other than a couple of pins. So that's a pretty cool one right there. I don't think we have anything specific for feather other than some of the feather doublers, feather screw terminal, proto board, a couple things like that. I don't know if there's a Pico PermaProto. No. There's a Raspberry Pi one that breaks out the 40-pin connector, but not for the Pico. Since I'm here, actually, another thing I wanted to show and get into. Yeah, let's pivot to this thing. So I'm going to leave that up so I remember. I'm going to come over here for a moment to my workbench, and let's put that little view there. So this I showed on Show and Tell last night, if you were able to tune into that. This is a little bit of a progress report on Larzio Paint music program for the Fruit Jam, and the version I'm now actually focused on, which is the port of this to the Metro RP2350. So I won't go into the full story of this, but I will just to compare and contrast. Fruit Jam is the same RP2350 chip right there from Raspberry Pi. There you can see it there. That is the same chip. Most of the specifications of the board are identical. A question came up earlier. David Gladet asked if you're matching sort of as close as possible between a Metro and a Fruit Jam, do you get the PSRAM version of the Metro or not? Yes, get the one that has PSRAM. I'm not using it knowingly for anything in particular right now, but it is. We have a version where that is not soldered on. You can buy them and solder them on separately if you want, but the Fruit Jam does have the PSRAM on there, unless I'm wildly mistaken, but I think that's the same layout there of flash and PSRAM, flash and PSRAM. Some of the peripherals that we're using for treating this like a little miniature computer are having video out over an HDMI-shaped DVI, digital video interface connector. So that's what you can plug a typical HDMI cable into there. Hold on one second. This air conditioner is blowing right on the desk. I'm going to turn that off for a minute. That's better. And I do want to bring up my Discord just so I can make sure everything's copacetic there. So to be able to have the Metro match the capabilities of what I need for Larzio Paint Music and other sort of game console, 8-bit computer style things that we're doing, we want to have the video out, and so for that I'm using the HSTX interface here and a 22-pin flex cable over to this HSTX DVI output board. So that gives us the same functionality as that HDMI DVI connector there. We have two USB-A ports on here that we can plug in a mouse, keyboard, gamepad, those kinds of things. For Larzio Paint Music, I'm just using a mouse, so I need at least one USB host on here. So we do have a USB host built in on the Metro board. This one's hard to see. I'm going to zoom in just a little more if I can. That's the limit. There is a set of 4 pins right here on the Metro that give us 5-volt, ground, and then the 2 data plus and data minus. So those are built right onto the Metro, and you could slice a mouse cable open and solder it right on there if you wanted to. I don't have my connector here, but we have a nice little USB-A to header pin breakout that you can solder onto there, plug in solder on a socket and then plug it in. I've soldered on a little socket here and then run wires over to, instead of just the breakout, I'm using a USB hub. So this actually also has this, what is it, CH343 USB hub, which is configured for 2 ports on here. I think the chip does 4, but I think it's just the board here is 2, and actually in this case the board here is 2. And so then that means that we are upstream to the Metro and downstream to a mouse over these, and we could do a keyboard over here, or you could use the 4-pin, the 4 output one if you wanted to. So that gives me the mouse input. I mentioned this on Show and Tell yesterday. There's going to be a build of CircuitPython that should eliminate the need for the hub if you're just using a single, hosting a single USB device. Right now, at least a mouse is the low-speed USB 2.0 mouse, I think causes problems with some timing. So Thatch and Scott have been working on putting together a fix in Tiny USB, I believe, that'll deal with that. And then we have audio output. So on Fruit Jam, you can see there's a nice little TRRS jack on here, 3.5 millimeter. And we can do headphone out over that because it uses the TLV320 DAC. This is that DAC, and supporting circuitry in a convenient little breakout. And in fact, on the Fruit Jam, we have a little speaker output here, and we have that little speaker output here on this DAC breakout. So that is essentially the list of parts you need to replicate that. And so 2 things I want to follow up with on that. I'm going to grab the Fruit Jam and head back over here. I'm also going to turn the AC back on because it is starting to get hot again in Southern California. I think we're going to be in the 90s this weekend. So the 2 things that leads me to want to show you. First of all, what are these parts? Because it's actually, I think, David with the ham radio looking name, something 09 New York. I'm not seeing you in the chat now. Where'd you go? Asked about the list of parts to do what I did there. So here they are. It's the Metro RP2350 with PS RAM. And you know what? I'm just going to add these to the cart as I go. Hopefully they're all in stock. We've got the TLV320. Add that to the cart. We've got the HSTX DVI breakout. I'll add that to the cart. And we have the CH343 2-port hub. Add that to the cart. And then that right there is so tiny. Let me zoom in on it. That's the list right there. In fact, it's kind of an interesting thing. You'll see, I'm not sure what we have the Fruit Jam priced at, but this is what, it'll be cheaper than that, I'm pretty sure, because this is, I mean, never say never, because who knows what tariffs will do. But at the moment, getting the Metro plus these parts costs $43.90. Yeah, this is kind of the exploded fruit jam. I don't know what else I'd need. I guess a strip of 5 neopixels, and then we'd be pretty close to everything that's on there. So take a screenshot of that, David. Oh, David Glade, it was your question. Okay, yeah, also, that's right. You do want your flex cable. So when you go to get one of these, you'll see some flex cables. I think the 100 millimeter might be the one I have. No, I'm using the 200, 20 centimeter one right there. That's the one I'm using. And the USB-A breakout, I'm using this one here. There's also that one there, so you can just flip your, oh no, that's, yeah, don't get that one. Get this one, it's out of stock right now, or just carve up a cable if you need to, but that's how I'm connecting to the board with the mouse, so that I can plug the mouse in and out. We have a few other solutions for that kind of thing that you can find. I think that's it. Yeah, so that should cover it. Thanks for putting that list together. Oh, you can't see my screen. Yeah, great. Thanks, Todd. All right, good. So that's the, we don't have this in stock right now. That's the USB connector you can use. And then if you just look at my cart here, those are the parts that make up my exploded fruit jam. So Metro RP2350 with PS RAM, the TLV320 breakout DAC, the 22-pin HSTX DVI adapter, CH334, I keep saying 343, CH334 2-port USB hub breakout, and then a flex cable. There you go. Hopefully that'll do it for you. Okay, the other thing related to this project I wanted to do, let's go to my code view, and I'm gonna unplug the little cutie pie I was using. Set that over there. And let's plug in this fruit jam. It's not gonna do much, it's just gonna error because I don't have any of the I2C peripheral plugged in, so it's going to bug out on that. But what I wanted to show you is a little section of the code related to, let's close that, related to the decision of, are we running on a Metro RP2350 or are we running on a fruit jam? So I had developed this originally on the fruit jam, porting it now to the Metro RP2350. So the first thing I did was comment out the differences, which aren't many. Honestly, it is the I2C pins and the reset pin for the DAC. So if you look at the internal versus external types of things, all of this is basically on board except for this. So HSTX is basically an onboard peripheral. We're just extending it with this little breakout. And so talking to that display is no different on the fruit jam versus, which also has that. It's no different on the fruit jam to the Metro. So those are the same. Talking to a USB host device is the same, even though we have it sort of broken out externally with that hub. It doesn't appear any different. So the only difference is how we talk to this TLV320. And so I should amend that. It is the I2C, and that's almost the same. We might even be able to get away with the same. It is the I2S that are different pins that we're using for I2S, and that's because Fruit Jam has I2S pins in the board definition named things like I2S B clock, I2S word select, I2S DIN. For those on the Metro, we're grabbing GPIO pins, general purpose. So I've got pins 9, 10, and 11 there for the DIN B clock, or word select and B clock. Also, there is an internal pin called peripheral reset on the Fruit Jam that resets that DAC. That DAC needs to be toggled low and then high in order to work properly. Sometimes you get lucky, which I did for a week until finally a little more told me why I was having so many problems was I wasn't resetting it. I was just getting lucky sometimes. So now I'm explicitly resetting it when we start up with a pin 7 on the Metro here, or the internal peripheral reset pin. So what I need to do in order to run the same code on both boards, after I got it working here, I said, all right, I don't need to be maintaining separate chunks of code. I just want to have my code find out which board we're running on and just make that one small difference. So if you look, it happens to be this chunk of code called soundmanager.py is where I'm doing my initialization of the DAC as well as some other setup related to sound. And here is the code I came up with based on one of Toddbot's tips and tricks, CircuitPython tips and tricks that he has on finding out the board name of the board you're running on. So when I go to set up the DAC, we import bus I/O, digital I/O, and the TLV320 libraries. And then I'm importing OS, and I'm creating a variable called board type, which is equal to os.uname parens .machine. Then I can simply test for a string in that board name that comes back. And I believe there's a newer, better, neater way to do this, but this one is working well for me. These are the two options I've got. Either it's a Metro RP2350 in the board name, in which case my reset pin is on D7, and my B clock, W select, and DIN pins are these 9, 10, 11. Also, I'm using I2C as stemma I2C, which on the Metro, I will point out, is both the stemma QT port and the SCL SDA pins right next door. So you can call that stemma I2C, and it'll work either way on the Metro. If instead the board name has Fruit Jam in it, then we're going to use, instead of pin D7, we're going to use pin perif reset. We're going to use bus I/O I2C, board SCL, board SDA. And we have these sort of internal nice board names for B clock, W select, and DIN. That's it. After that, it's instantiated. It doesn't care which board it was on. Everything works the same. So I was excited to do that. I'm not usually that thoughtful a coder, and I pay the price later, but I decided in this case I really don't want to be maintaining separate. If I make one change, oh, I got to remember to change the Metro version. So here hopefully we'll have board agnostic versions. I know there's other smart things I could do, like else say you're not running on the right board at all, you know, throw an error and say, hey buddy, this you shouldn't be trying this because these are the only two boards that are allowed. So there's certainly more I can do there, but that is how I set this up for having a single piece of code supported on the two boards. All right, so that's that there. That's the status on that, and I'm pretty close to just pilinting. I say just pilinting a whole ton of code that's running on this, on both of these, and putting that up on GitHub, and then writing up the Learn guide for this, and then eventually when Fruit Jam is available, you'll be able to run the same code on that. Also, if you didn't catch last night's show and tell, go back and check it out, because there's a really cool project that Tim C is working on, Foamy Guy's working on, which I think he's calling Fruit Jam OS or Fruit OS, but it is a an operating system on the Fruit Jam that lets you do selection of which code you want to run, editing code. It'll let you have a screen, a mouse, a keyboard, treat it like a little computer circa 1980. And he's got a number of apps and games that are have icons, and you can launch them, or you can launch them from a text launcher. And I would love to see if we can get the Larzio paint music on there as well. Hopefully it's not too big to fit, but it'll be cool to get that running on there with the little interface so you can pick it to play. Okay, let's see. Other question. Oh, I was looking at the wrong chat. Sorry. On my phone when I was standing over there, I was in the wrong chat room. But looks like there were no panics. Good. Okay, so moving on. Here comes the fly by the seat of our pants section of the show. So I've got a project coming up, as I mentioned, that's going to use two Sparkle Motion boards that are going to be in sync with each other. So I'm starting this exploration with two Sparkle Motion minis that I happen to have on hand, and they both have pretty much identical setups. They each have a little NeoPixel Joule RGBW on them. One is RGBW cool and one is RGBW warm, but otherwise it's the same. So these are fresh installs on here, and I wanted to go through the process just because I need to learn it, and thought it might be interesting to see it, of taking fresh installs, configuring them, and seeing if I can get the two of them to sync with each other. The big challenge with this tends to be we are dealing with Wi-Fi. After the initial install, we pretty much are using Wi-Fi exclusively to adjust the settings on these things. And that means I can't really use this computer to do some of it because that could potentially mess with broadcasting. We'll see. So I may just use the phone and show you the phone as we do this. But we kind of have to have everything on one network at the beginning, and then if that is successful, we're going to turn one of these into an access point that the other one syncs with. Reason for this is that if you're doing home-based stuff, you can use your local Wi-Fi and sync no problem. That's what we'll try first. If you are taking it out onto the dance floor or a festival or wherever, these two won't necessarily be connecting to an unknown access point that's out of your control, and so it's going to be better for the two of them to talk to each other or to a third one, so that they can stay in sync and communicate with each other without needing an external access point. So that hopefully lays the groundwork. So I'm going to start off with, let me give you a view of what I'm doing here. And this is where I'll change back to that WLED install screen that you saw earlier. Okay, let me find that. There you are. Okay, so I have this one here plugged in. I have just installed it. If I go and pick, it just popped up a window that you won't see. I picked the serial port over USB. It just says, hey, you want to install this again, or you want to look at logs in console? I should preface all this with I am a newbie on WLED. I've just done a little bit on it, so you may be screaming at me that there are better ways to do what I'm doing, and please do, because I'll listen. But what happens at this point in the installer, it is supposed to pop up a window that says, hey, do you want to configure some Wi-Fi settings so that you can actually see this thing? That doesn't always happen, so that's okay, because what you can do, and I'm going to put my phone under the camera view here, and hopefully you'll be able to see that. And I'm going to make some windows smaller and bigger. Let me make this easier to see for you. Hold on. Oh, hold on. There, it's better. Let's bring this back into view. Okay. There, okay, so that's a little bit bigger. So what you can see right now, my phone is on an access point here in the workshop called ShopNet. Down at the bottom here is other networks. So when this is a fresh install, it actually, since this has a Wi-Fi ESP32 chip on it, it's broadcasting a little captive network. And so if you don't get the option to change the settings on the board, you can go and connect to it directly. It has They should have no password. Let's see. Oh, let me go to, yeah. I'm gonna make sure this is the one I'm thinking of. See if that goes away. I just unplugged power on this. Oh no, that's some other one. I don't know. There is another WLED somewhere here which I thought I had unplugged. I think that's that one. Let me forget this network. Will it let me? No, it doesn't think I've been on it. All right, so let's plug this one back in and see if a new one shows up. You're not supposed to have a password. Is that really you? No, I don't think that's that one. All right, so why is this one not showing? Let me just try the other one first. Or did I already put these onto my network? I don't think I did. They may be remembering some settings. Let's see if this one shows up. WLED AP. No, you're not supposed to have passwords. What? Yeah, that's not it. Okay, so let's see if these are actually just already on the network. Let me run WLED. No, those are not these two. Okay. Let me go onto my other network and see. Come on, you can do it. Connect. I'm going to just hold it up for a second because there's a lot of stuff in the way. I don't think those are on that one. Yeah, those are inside my house. Those are not this one. Okay, so let's get back on the... Why would you have... All right, I'm going to reinstall on this one. Let's see if it changes it. Sorry about this. This is going to take 2 minutes for it to install. Yeah. Just looking at the YouTube chat. Thanks, Dave Odessa. It's a neat bit of coding on the Fruit Jam thing. The Autograph Abdelhagen says, has a couple spare APs floating around just in case. No doubt. Okay, so this one right here is getting a fresh install. What I hope is that it either pops up the, hey, do you want to adjust your Wi-Fi settings? That would be great. Or that it does show up as a fresh access point, a WLED access point. I am perplexed by what is plugged in. I really thought I had unplugged. Yeah, there's one over there that's unplugged. That is DMX stuff. I don't think I have another WLED thing, but clearly I do. How about that? In the meantime, actually, I'll show you. I'm going to bring up a WLED Learn Guide, actually for Sparkle Motion. By Aaron St. Blaine, who knows this stuff inside and out. If we look at WLED setup here, this is what I'm going on the Mini. I'm not bothering with this special firmware for version 16 because I'm not using microphone right now, but I will be. But here we go. This is install.wled.me. That's the installer we use. And that's just finishing up right there. I should pay attention. They say keep this page visible to prevent slowdown. Okay, installation complete. Next. Yeah, so this is where it's not popping up. Oh, but did you see that change? Okay, so WLED AP popped up. Can I just Why is it saying password? I didn't think these had a password, do they? That is perplexing. Oh, no, it's saying WLED 1234. Why do I feel like I've never done that before? All right. WLED 1234. I must have had that saved. Okay. Mystery solved. Okay, so now my phone is connected to the access point of the Sparkle Motion. This is why I didn't want to have my computer connecting to this, because I have some concerns about trying to broadcast this show, which is over Ethernet, to be fair, but changing Wi-Fi networks in the middle of that kind of makes me nervous. So you can see here on the phone screen, Wi-Fi settings. I'm going to go and put in this ShopNet. So you can hit scan, and it finds kind of the most powerful network and lists it first. So that's ShopNet. I'll go ahead and pull this away and enter in the password for that. That's been entered. And I think I'm going to leave everything else alone and hit save and connect. So this Sparkle Motion now is going to jump onto that ShopNet access point. Excellent. I can cancel this, use other network, go back to ShopNet with the phone. Cool. Now what I'm going to do is let's test this one, and then we'll get the other one up and running. So that means I should be able to go to the WLED either web page or the app. So I'm going to use the WLED native app. And since my phone's on ShopNet and the Sparkle Motion here is on ShopNet, when this refreshes, we should see this new Sparkle Motion on here. It won't be WLED rose, it won't be analog neon. And let me reset or power cycle this as well, just to make sure that it actually gets on that network. It will either have a fresh, clean install name. I can't remember if I wiped, I had given it a name. So we'll see if that shows up. Okay, so that should be connected. And am I really on ShopNet with this one? I am. Okay. I'm going to relaunch WLED just to make sure that we're... There we go. Okay, yeah, so this is a clean install that just shows up as WLED. So if I connect to that with the WLED software, first thing I'm going to do is give it a name. So up in this very top gear icon, I'm going to call this one right. Just call it right. What I'm going to be making are going to be some shoes that have a transparent block in them where the LEDs are going to be lit up for a drag artist friend of mine. So we're going to have synced up LED shoes, hopefully. So for now, I'm just going to call them right and left. So we'll remember right is the one that has the little diffuser on there. And now let's configure this one. So under config, Wi-Fi setup we've already done. LED preferences, we're going to say this is a set of 7 on this. Ultimately, I think I'll be using something more like these, but just for testing now, it's nice to have it kind of short, compact on the desk. So these are, the number is kind of one of the most important things on here. The type, these are RGB W. Let's see, WS. Is it WS2811 white? No. I don't know which ones these are, these RGB. Let's leave it at that. It'll be wrong colors at first, but I just want to get it up and running, and then we'll fiddle with that. Second most important thing, maybe the first most important, what's the data pin it's on? So with the default is it's picks 1. On the Sparkle Motion, it's going to be either pin 32 or pin 33, depending on what you've soldered or plugged into. So I'm on pin 33 with my data. So we'll type that 33 in there. Let's say done. I'll save that. And if we go back, you can see it's lit up now. I can dim it. And you can see it's not the right color. So if I tell the whole thing, be red, it's not. It's a mess. So that's because these are RGBW and I'm sending them RGB code. So let's try to fix that configuration for the LED preferences. So not WS281X. Maybe it's 281 white. I think that's for like a white only LED. I don't think that's RGBW. Let's find out. Oh, no, it definitely is wrong because it thinks this only has brightness. Okay. So I thought this was obvious. What am I getting wrong on here? Maybe it's just pick RGBW down in the color order. That might be it. So let's try back there and then color order. No. Oops, I've picked something crazy now. What are you? Let's try this, WS2814RGBW. Maybe that's it. And save. I think that's it. Yeah. Okay. Great. So red, green, blue. That's a really good test to do at first, just to make sure you do have the color order right. Otherwise, you can kind of write those down and figure out what it thinks it's sending versus what you're trying to send. And I'm going to leave it here, but I'll make one change. If I go to sync interfaces, I'm going to tell this one to send whatever happens over sync group 1. So when these are on the same network or one of them is acting as the AP for the other, we'll start with that first case. When I change this one, it will change the other one. That means not only do we not have to have two interfaces up, we can just pretend it's a single object. If this one is doing a sequence of scenes that have timing, it will tell the other one to do those as well. If this one is listening to IR remote, it'll tell the other one what to do. If it is sound reactive, it'll tell the other one what to do. I think that works. So I'll hit save to that, and then we'll go back here, and let's do it all over again on the second one. So I'm going to go out to Wi-Fi. I'm going to unplug the right one, and now this is what's going to be the left one. Plug this in. I should be able to see the glow of those LEDs. I'm going to point them at the screen because I don't have a diffuser on them. So once again, this one I installed WLED on. I'm going to go connect my phone to its access point. Thank you, Betagraph Abdelhagen said, I think it's the SK. There you go. Oh, and Toggle Switch was helping me out. I missed that. Thank you. It has the default password, WLED1234. I really completely botched that. Okay, so I have just connected the phone to this second one, the left one. Let's go to Wi-Fi settings and get it also on the shop network. So I will scan, just so I don't have to type it. ShopNet, great. I will type in the secret password. Lars. And now this Sparkle Motion will get onto ShopNet. So I'll put the phone back onto ShopNet. I will maybe reset and power cycle this to make sure it gets on the network. I don't think it does at first. you know what? Sorry, I just realized I'm not doing anything right now on that screen. Let me hide that one and we can just see everything else nice and big. Okay. So with the phone on ShopNet, that's a good sign seeing WLED AP disappear, because that means this one is not broadcasting that anymore, which I think it does at first, and then if it connects to a Wi-Fi, it makes that one go away. It can only do one. So let's go to WLED, and now we should see left show up here. I think it just needs a refresh or some time to do that. I think it tries to find it for a while. Let's see, it's not there. And this one should just show up as WLED, this new one, since I did a clean install and haven't messed with it, I think. All right, I will quit WLED, relaunch it. I'll power cycle this. There it is. Okay, WLED. Maybe a cache needed to be flushed or something. So this is this one here. The first thing I'll do is name it to try to keep sane. So this one's just going to be called left. Done. Out. Config. We did Wi-Fi setup. We will go to LED preferences, set the number, the pin, and the type. So type is this. Length 7. Almost hit delete on my keyboard. Pin 33. Yes. Save that. That's a good sign. It just lit up. Go back to here. And then also in config for sync interfaces, I'll say receive on sync group 1. Hit save. And now what it can do is, I'm going to back out of here on the interface. I'm going to power this one up. And at this point, I'm using USB-C that happens to be plugged into my computer, but it could just be a battery pack at this point. I'm not doing any serial USB stuff or anything like that. We've already installed. Okay, so now the right one is on the right here with the diffuser. This is the left one. They are both on ShopNet. My phone's on ShopNet, so my phone on the WLED app is finding both of them. If I go to the right one, which is the sender, and make a change, it should tell this one what to do, but I forgot to hit sync. So there's a button up here that says sync. You can tell it to automatically turn on sync if it's a sender. On startup, we'll set that in a second and see if that works, but I forgot. So now, oh, it didn't work. Okay, so sync on this one, and this is, make sure I've got, you're on ShopNet. Left one, you're on ShopNet, okay. Right one, sync interface, send on 1. Good. Left one, config, sync interfaces, receive on 1. Let's just change them to 2 just to toggle it. Left, receive on 2. Right, send on 2. And turn off sync, turn on sync. Let me just go check. Does the other one also need sync turned on to receive? Yeah, maybe they both need to be. Oh, no. Okay, I did get this working earlier, so I know it should work. But now we're confused. So if anyone's an expert in this, let me know what you think I'm missing. Let's look again at the sync interfaces. So UDP, sync group 2, enable sync on start. I'll go ahead and turn that on. I didn't change anything else here below when I was testing this before. So we'll hit save. We'll go back. I'm going to tell the other one also to sync on start. I think that's only for sending, but. And now I'll go back. Let's power it down. Power it up. Power down, power up, sync off, sync on, test it, nothing. Okay, let's power cycle them. Todd asked in the chat, do you need to sync button on the receiver too? I feel like I didn't before, but I'm not sure. I think they're coincidentally the same color right now. Yeah, they're not synced. Let's go ahead and tell the left one. I just want to change the color on the left one, make sure it's working. Yes. All right, let's turn off sync. Let's turn the right one to sync. Let's turn the left one to sync. Right one. No, they're not syncing. Why is this? All right, let's ask the internet. Go over here. So Aaron has a project that is really similar to what I'm trying to do here. So I'm going to check that one, which is laces, some boot laces. Reboots, animated LED bootlaces. I think it's those. I think. No, those are an older one. WLED. Let me just type that. Synchronized NeoPixel bootlaces. And hers go the step further that I'm trying to go to eventually, which is that AP mode sync. But even before that, I want to see. Right shoe host setup. Yeah, see, I'm not trying to be a host. And this is kind of the easier scenario that the other documentation I've seen says should work, is just having them on one AP. Receive box, yeah. Not in AP mode. Nope, neither of them are. Troubleshooting. Yeah, one thing is things get confusing, so naming them is nice. Yeah, I got WLED native. All right, not a lot in there troubleshooting-wise. Let's Google this. WLED won't sync. Sync not working. Make sure you reboot after changing the settings. Check the sync button on the main pages on. Okay, let's do one thing, which is I want to tell the left one to sync on start, and let's reboot them both. User interface. No, sorry. Yeah, left one. Config sync interfaces. Yeah, I have enable sync on start. I'm not sure if I need that or not. So let's do a reboot from here. Does that do anything? Even that should work, just the dimming. And let's try a reset. It's funny, I think it just resets to that color, but they're not synced. No dice. All right. Turn it off and on again. Yeah. Let's try it. Nope. I'm at a loss. Oh, sorry, you're not looking at this. Let me put this back on. Sorry about that. So, let's see. It should be on the same build. 2412 42100, yeah. Reboot WLED? Sure. I like that. I'll reboot the other one too. Reboot, yes. No dice. All right, I may be out of patience. Oh, we're out of time too. Okay, well, this is as far as I've gotten. Stay tuned for next week when I surely will have triumphantly figured this out and can show you what my silly mistake was. Send on multiple groups, listen to multiple groups. Just checking this troubleshooting here. UDP notifier function WLED makes it easy to sync multiple lights on the same color effect enabled by default. Set up a specific behavior, sync settings, choose all aspects. Sync quick toggle. Only turns on and off. Do you think I need to turn on UDP like on my router or something? Some nice mention that it uses UDP. Do I have it active on my Wi-Fi? This is such a good question. All right, let me test. Let's I'm gonna do that in a separate window over here. Okay, I like this idea. What the heck is this router? I think it's this one. Yeah. All right. I should have a separate little router just for this that isn't the one I'm broadcasting on, but it's not the case. Let's hope that trying to turn on UDP will, yeah, you know what, I think that'll probably reboot the router or something terrible like that. Let's at least just see if it's on. Okay, admin, login. Okay, I'm in the router. And router settings. Searching for UDP. This is a router I don't use that much and have neglected, so I don't know it well, and I don't know if it's got UDP on or where I change it. Let's check maintenance. Oh, so David Glade says UDP does not need to be enabled, but if it does multicast, then most Wi-Fi needs that to be enabled. All right, I will give up on that. Yeah, that's gonna get boring real quick. So Oh well, that's as far as I'll take this today. Thank you for playing along that far. Hopefully that gives you an idea of at least getting these started up and connecting to them when you don't have them pop up their Wi-Fi credential box, which I found is more often than not the case. And I'm not sure if that's unique to different boards, but I've been having to do it this way more often than having it pop up its little Wi-Fi settings thing, which is too bad. All right. Standard deviation in the chat over on YouTube says, this is Bluetooth BLE. I always have issues with Bluetooth. These are actually Wi-Fi, so these use a ESP32 chip, and they're on Wi-Fi. Looks like, I'm just going to check one other thing on the config on these to make sure. Nope. All right. I will work on this and get back to you. Okay, yeah, David says there's no enabled disable for UDP. Only a firewall should block UDP, but local on Wi-Fi, it should be fine. All right, maybe that's not it, but I will try some stuff and I'll report back. Thank you. And before I go, I'll mention if you want to get yourself some stuff, maybe some Sparkle Motions. I think we still have some of these little mini ones in stock, maybe. Let's see. Let's go Sparkle Motion. Okay, so we have some of the full-size built-in antenna ones available, which are really cool, and you can run higher voltage ones. The mini Sparkle Motion that I'm using is just 5 volt, and then we have them with an external antenna, so you can get the little adapter and a little whip antenna and get much longer range. So hopefully these will work for my intended purpose, which is inside of 2 shoes with just the onboard antenna, so it doesn't have to get too fancy. All right, so that's one thing, but you could find all kinds of other things, and just don't forget to type in Maskatron in the coupon code field on your way out. There's going to be a deep dive tomorrow with Foamy Guy. Hopefully some more very cool Fruit Jam OS stuff. There may be some Desks of Lady Ada's on Sunday or other Saturday. Who even knows what is time? I will be back on Tuesday with a new product pick of the week. We will have Wednesday 3D Hangouts. Wednesday evening, we've got Show and Tell. And after that, Ask an Engineer. So plenty of stuff to come and see. And I will look forward to seeing you all over on the Discord chats and elsewhere. Thanks everyone so much for stopping by. For Adafruit Industries, I'm John Park. This has been John Park's Workshop. Bye-bye.